for tuning in. So we had been presenting this webinar series as under our initiative of AdMix. So what is AdMix, you would ask? So it's Additive Technologies academics drive that we had been taking off. First, we initiated it during the lockdown period to enable the innovators at home. So most of the people were uh, staying at home, and certain business meetings were going on live, but we thought that the best way to be connected with our client base, as well as giving them a chance what are the recent advancement developments that are happening, so that we are engaged and connected with the industrial community, as well as we opened this webinar series to almost all people, and couple of students as well express the interest to bring their skills up to speed. So we saw that that is a niche area we can try to fill in with whatever information as well as expertise we had gained over the years. So Objectify as a industrial player, we had been providing uh, additive manufactured engineering services to a wide spectrum of industries in India and across the world. So our client base is in South Asia, India, as well as ASEAN countries, Singapore, Malaysia, those countries, and some of the European and Middle Eastern countries like Israel, Dubai, and Germany, and some of the global OEMs like American MNCs. They are also our client, having offices in Singapore, US, and manufacturing facilities in India. So that's a brief about Objectify. We had been in this segment of industry for more than 7 years, and to commemorate the 7th year, we thought that we should take this initiative, that we are going through this kind of slowdown period in the industry, but we want to revolutionize and bring about the technologies and awareness, so that when we come out of this on July onwards, already in India many of the cities are open, very few hotspots like Delhi and Mumbai. So, but they are the commercial capital. So still some of the businesses are slower, and academics is totally shut down. So academic only live webinars and this type of interaction sessions are happening. Maybe certain academic institutions are delivering the coursework using this type of channel. So we thought we should be arranging this type of a session as well, and empower at least 5,000. So it's a goal that we kept to ourselves, that we are going to empower by end of this year at least 5,000 students. And we thank Think Create as our associate partner to cover the basic academics about this technology, how it is evolving. So we did a introductory webinar series of a 3D printing introduction. I think it's needing no introduction as such, because most of the media are covering what is latest development, what are the skill set required, how the industry is evolving, what type of problem it can solve, potential applications. So it is continuously evolving and developing type of technology, and lot of materials are on offer. So we covered first introduction. The second one was how you can plan for printing certain objects. So absolute imagination of shape and size is very key, and then you choose the materials, right? So that's why we covered the software that you can use to have a first impression or the first plan of just the size, shape, and functionality, how it is going to fit together with other elements, all that sort of nuances we covered, and a few specific applications as well that goes along with the software technologies. So you need to have a first impression, then you can go the for real creation. So mind map is always a kind of a way that people used to draft their ideas on a piece of paper as a sketch and then build their houses. So architecture industry is still the inspiration is with that fashion, that they sketch with the pen, then they add the level of details, and then they create the virtual models. Similarly, in case of engineering industry as well, people had been planning thoroughly in virtual space, and the computer-aided design softwares are such. So that we covered in a second webinar last Wednesday, and today we are covering the materials used, the types of material, choices of material. I think this will be a very interesting for academicians, because they are being challenged by the industry that the platforms are, as a 3D printing platform or a mechanism or flexible automation is in existence now, and it is rapidly being adopted. But qualifying different sort of material is a challenge, and a lot of experimental studies need to be done, and people can pitch in from academic background, students can contribute, they can come up with certain novel approaches. So that's why bringing academia up to the speed is also, as an industry, we feel that it's our necessity, as well as uh, it benefits the industry, and in overall sense all players who are involved and invested in this technology. So we are going to cover all about 3D printers later on, and certain myths busters, and certain remarkable feats achieved by 3D printing, so that what is out there and what could be possible is something on a high note. We are going to give a flavor to the academia and pose certain challenges as well. So certain myths we will bust, because there had been media hype as well. Quite a lot of promises are being made with the wrong impression that you need to just load certain material in a machine, and at a click of a button it automatically delivers you the brilliant object that you desire. So that is a wrong notion. There is a good amount of science and skills involved, and lot of learn and fail needs to happen, and there are good amount of robust machines, as predicted, as depicted by the media as well, that they are becoming very reliable. So we have those sort of machines because we are a service provider company. Once the commercial commitment happen, we receive the payments from customer, they expect the quality delivery. So in today's webinar as well, I am going to cover in terms of material characterization and how to ensure quality with that aspect. Uh, so let's begin. I think we have good number of audience who has dialed in, and it's 3 o'clock as well. So I will take you through the context and all. So Ashish, would you like to have a recap of the previous webinar? Can you briefly speak about the specialized applications and software solutions that you covered in the second webinar? Hello, Ashish.
Yeah, you can hear me?
Yes, I can. Go ahead.
So in the previous session, we talked about 3D printing softwares and some specialized applications that we'd shown. We'd shown you certain ingredients that is actually required to be successful in additive manufacturing. We talked about various, in the pre-processing stage, the knowledge of CAD that is required, various softwares that are available. As a beginner, how you could learn CAD softwares. If you want to move into sculpting, what all softwares are there? We talked about Sculptrix and various other softwares that are available. We also talked about certain advanced softwares that are there, like SolidWorks, CATIA, Creo, etc. And we slowly moved on into the simulation part, where we showed you why simulation is important, and various simulation softwares that are available over there, various FEA softwares that are available over there, and how you could simulate your part before printing it and understand where all you are lacking in supports, etc. And then we moved into the in-process stage. We talked about certain softwares which are used for quality analysis during the printing process itself. How you can learn, how you can actually get to know what all parameters are being used and if it is working effectively. And then we also talked about ERP softwares, enterprise resource planning softwares, and how you can centralize your whole 3D printing process into using an automated software, and how you can generate auto codes, etc. We also talked about certain specialized applications using topology optimization. We talked about certain applications such as conformal cooling. We also showed you a video on bioprinting as well. We showed you certain images on how you can make organs on a chip as well. So these were some of the main topics that we had covered in the second webinar. Now we'll move on to the third webinar, that is on absolute basics of 3D printing. Rahul sir, you can continue.
Yeah, thanks. So today we are going to discuss all about materials. So 3D printing, since its inception, there had been few very popular materials, but the advancement is happening at a very rapid pace. And how certain material can be qualified on a existing platform, and what are the new platforms being developed where you can get a novel characteristics and properties of a material. That is of a hot topic, and everybody is doing a research and development from industry standpoint as well as in academia too. So let's begin. So again, to introduce those who joined slightly late, so I'm Rahul Pise. I'm general manager of Objectify Technologies. I'm located in Noida facility. So we have two facilities in Delhi NCR area. In Delhi, we have at Patparganj polymer facility, and in Noida, we have a metal additive manufacturing facility. So we can print a variety of polymers as well as a lot of different alloys of metals as well. So be it ferrous or non-ferrous alloys. So let's begin. First of all, I would like to understand the audience makeup so that I can frame my presentation as well as give illustrations and level of detail information accordingly. Sankha, can you run that poll?
Yes. Okay. So I'll be running a poll right now. I would request everyone to kindly pitch in your answers. Yes, sir, the poll is live. Give it a couple of seconds. Hopefully, we'll get all the answers soon. I would request everyone to please cast in your answers so that we can gauge the kind of audience we're dealing with.
Thank you, Sankha, for running that poll. So I will begin with the overall highlight what I am going to discuss today. So we are going to discuss about different phases of material, because phase is something that needs to transform in order to get from raw feed of a material certain finished items. So that's why the phase change is very key in terms of materials. Then we will talk about different strata of 3D printing materials, means what are the basic forms or the phases in which the material can be fed to the 3D printers. So it can be liquid in terms of polymer, resins and wax and jelly format, semi-solids, fluid mixtures, jelly again, or some sort of proteins or biogel to make scaffolds, all that sort of semi-solids, and solids, of course. So solid to solid conversion happens with the certain energy, and phase change is going on, but solids are fed in a form of powders, rods, granules, filaments, and sheets. So these are the format, three types of format the material is fed to the 3D printer machines. We will go through the material chemical as well as physical properties and how it affects the quality and desired end use performance. So end use performance we need to characterize, just like in any story you need a hero and its character development happens. So similarly, if you want a hero material to perform against your project objectives or your end goal applications, you need to characterize that material and write that story very firmly. And testing and test methods is the key by which you can characterize the materials. Then where those materials come from, I will briefly touch upon. So the production, where are the big production houses and which are the supply sources of those materials. And I will cover certain specialized applications which are paving a path for further developments. So that is a brief outline what I'm going to cover. So let's begin with one by one. So very basics of material and
Sir, I'll be
chemical.
releasing the poll results so that you can actually have a look at it.
Yeah,
Is it
it's
okay?
yeah. Please post it. It's very timely. Yeah. So
Yes.
I think most of the people are either aware or having a good amount of understanding about engineered polymers, engineered alloys, and material developments. So very few people are having no scientific background, but they at least have a level of understanding with their hands-on use. So they didn't pursue a basic education in material science or something, but they are everyday using and they know the terminology, they know the properties, they know how it should be judged. So I think it's a good mix of people, but most of the people are aware about basics. That's a good for that is good for me as a prerequisite that I can explain a little bit more advanced stuff and also cover the basics for those who are absolutely novice. So let me begin with the basics first. So as I mentioned, the material, the characterization of that material, the character development is something very crucial for any story writing, right? So when you are creating something and expecting performance out of it, be it a human being, a living object, or a durable product or a perishable product, whatever it may be, its story is very important, and the character is something that writes its story. So the structure of the material, the properties, the performance, and processing revolves around the character. So material characterization, I think the character of water we know very well. So that's why I showed here the phase of water. So liquid water to a solid water, how it does the phase change. So and solid to a gaseous state, all that sort of terminology is very basics, and people are aware that solid melts to a liquid, and again when it cools down it becomes a solid. So that's a very key transformation we will again and again touch upon. So this is something as a basic science people had been using since the Bronze Age. So Indus Valley civilization, this one was a figurine, bronze figurine made by lost wax casting method, and that method is still valid today. Most of our automotive components are either die casted or sand casted, and over here I am showing one of the example of that. So automotive engines have the piston and cylinder assembly. So this is the piston head of the engine, and it is die casted. So you are essentially melting a specific alloy uh, that it gets into a cavity, and once you open that cavity you get the part which is solidified inside that cavity. So that's how the basic processes are. Gaseous state transition is something we will ignore, because in for the most basic 3D printing processes, only solid to liquid or liquid to solid, these phases, these phase change transformations are most often with the temperature in place or certain polymerization chain reactions in place. So let's begin to general strata of the materials being used. So some of you are familiar with these materials or have used firsthand. I think the desktop machines are more popular, where wire filament fed, uh, it's very cheap as well. So around 50-60 dollars, means around 2000 rupees or something, you can get a spool of this wire and feed into a 10,000 or $15,000 desktop machines. And I think some of the academic institutions as well are hosting this type of machines just for basic awareness and experimental use. So that's a fuse deposition method. So ignore these acronyms. We are going to cover a separate session about the mechanization as well as automation, that sort of platform developed by different machine makers. So today's focus is mostly on types of material, in which format that material is fed, and how to characterize that material. So in case of polymer, we have liquid resins in powder form or in filament form. Certain polymers are fed, or certain granule format as well. So this is very common format of material being fed in conventional industry as well. and in 3D printing as well, the similar format of material is being utilized. The filament format is something very popular, but atomized powder format, granules, as well as liquid resin is more popular with the industrial grade 3D printers. Similarly, in case of metal as well, you can form wires like filaments and powders. So those two formats, or sometimes certain rod fed machines are as well there. So these three formats of a solid uh, alloy uh, to be fed in certain machines to form certain geometry. So we will go into details how those materials are made, how to characterize its property, all that sort of stuff. So uh, again, with the general strata in context of 3D printing technology, just ignore these terms of which specific acronym being used for the technology. Look at the materials, how its transformation is happening, and what is the quality that you can expect in terms of durability, surface finish, level of detail, or resolution of a geometry printing process and its application. So starting with the horizontal row of ceramics, so that you can do either binder jetting or using laser melting, you can form ceramics. Metal, mostly melting processes, so it can be using laser or electron beam. In case of sand, again it's binder jetting. Plastics, plastics has a wide spectrum of different possibilities. So uh, the wire filament fed is melted and resolidified, right? So that is very much popular, and you might have seen those sort of printers. So that's the filament fed machine where melting and resolidification is happening. Similarly, powder fed, in that case as well, the focused beam of laser, high power laser beam, locally melts, and again you get it solidified. So that way of melting and resolidification is happening in polymer. But there are special grade of photopolymers which are popular as well in industry. The photopolymer is something I will explain in detail as well. So when we go to the absolute basics, I will cover how that phase transformation from liquid to solidity is happening. Then wax, you know, the wax is very popular. The first Indus Valley civilization example, in that case as well, they used a wax figurine to make a artwork first and made a cavity by lost wax method and then poured the bronze inside that. So similarly, industry uses wax patterns quite often. Even jewelry is made in this fashion, and it is using the material jetting. So the wax is liquefied and again it gets solidified when it cools down. So I briefly explained how the quality judgments are happening, but it is very vague in this just one overall summary. We will go dig each aspect in detail one by one. Okay, so here is just a definition of what is 3D printing material. So any sort of material that you can do deposit layer upon layer to do either phase transformation or just have a adhesive bonding. It can be extruded, selectively sintered, melted, or welded, whatever the process may be. But instead of taking a material from a solid chunk or directly pouring in a cavity, the shape is formed by slices of layer upon layer deposition. So that is what 3D printed materials are, and most of the materials that are possible are metals, polymers, ceramics, cements, glass, composites, cellulosic materials, fibers, and some of the organic material as well in recent cases. So how can we classify these materials? So I think the basic elemental physics, you know. So the elemental pure substances are there. Those substances form bonds. It can be ionic or covalent, and those are compounds. And either elemental and compound mixture can be there, or just compound mixtures can be there. And those mixtures can be homogeneous or heterogeneous. So based on that, I gave you a visual of a few good examples. So I think pure gold, 24 karat. I think people are aware of that because of a high value. So it's very malleable, ductile, and in its purest form, nobody wears it because it's too malleable and it will deform its shape very regularly. So that's why they add certain impurities to pure gold, making it either 18 carats or 22 carats with the addition of copper based alloys or certain other alloys, so that what happens, it forms a fused homogeneous mixture, and that 22 karat gold can be mended to a specific artwork jewelry type of geometry, which will so that's why most often in case of engineered products, you are looking at mixtures. Those can be either homogeneous and heterogeneous. So the most homogeneous are alloys and certain polymer grades. Those are homogeneous mixture. Heterogeneous mixtures are rare, but they are getting popular recently. So the most of the composites, cellulosic material, or advanced bio type of materials that I mentioned, those are mostly heterogeneous. So what is the difference between homogeneous and heterogeneous? So you can see glass is a best example of a homogeneous material. It looks so transparent when it is fused and bonded, but if its in constituent parts are looked at, they are very opaque and not crystalline. So silica sand, soda ash, limestone, all other sort of ingredients are added to a crushed glass to initiate the nucleation of the crystal formation, and then you get a brilliant transparent outcome, and that is a homogeneous example. So similarly, stainless steel and other alloys are a kind of homogeneous mixture which has a iron as a main ingredient, and then you have addition of certain carbon, uh, some impurities of phosphorus and other stuff like sulfur, phosphorus. Those are impurities, but deliberately you add either chrome, nickel, molybdenum, all that sort of mixture of pure elemental alloys, substances forms the alloys. And if you look at the its characteristic under microscope of a 10 micron size, you still see the mixture which is homogeneous. So it's not heterogeneous. But in case of heterogeneous mixture, all the organic substances as well as some of the naturally occurring ores like granites and those sort of materials, you can see it is consisting of quartz, feldspar, mica. So these type of substances are heterogeneous. And in case of polymer, going back to the specific compounds that are popular in case of 3D printing polymers. So polymerization is a chain reaction that happens with certain activation energy under the presence of catalyst. So the monomers are commonly known like ethylene, polymer compounds, and polyethylene and polypropylene is more popular grade of polymer that we everyday use. Similarly, in case of 3D printing, acrylobutadiene, styrene, ABS, that one, and uh, other like acrylates, nylons, these type of polymers are very popular. So I will go through the I will go through the details of each grade later. So I'm sharing with you the different sort of chemical and physical properties you need to characterize. Once you know the basic construct and makeup, you need to ensure that whatever you are claiming a specific stainless steel grade like 304 or 316, how you can characterize and define its quality based on its pure form of ingredients in a specific mix, that you have to do a test method to identify and check the consistency continuously. So that is something as a services offered by certain labs and certain manufacturers. So there are a long list of methods. So in case of material, chemical composition is one thing, once that makeup is established, after that you need to do mechanical testing so that you know its behavior in terms of its tensile strength, its hardness, its flexibility or ductility. Can it be welded? How dense that part is going to be because of that? Is it going to be heavy or light? Its magnetic properties. And there are non-destructive methods as well. So you don't have to again and again break the parts to do the characterization. There are latest methods by use of X-ray or ultrasound or other kind of methods which are non-destructive type. You can still characterize the quality of the material. So these are the typical classifications of the test method. But I'm just listing over here for your uh, basic understanding. You can refer to the metallurgical courses or material science courses and go to the absolute basics, how the performance is tested and justified for quality after the test results are submitted. So in case of most metal, you might be aware that they do the tensile test to understand its Young's modulus, so that how tough it is under load. That is something checked at, looked at. Similarly, compression test is done for most of the building material. They do to find out the compressive load that material can take up. So bricks, reinforcement members which are made up of steel.
Hello. There seems to be some technical difficulties. Rahul sir, are you there?
Yeah, I'm getting back in. I
Okay,
think
okay, sure.
some issue. So
Okay, okay, everything is fine. Back to normal. Yes, yes. Continue, sir. Yes, sir.
thank you. Okay, so I was briefly explaining different type of mechanical strength and that sort of characterization test methods. So the one that I mentioned was tensile and compression, and then there can be a torsion test if it is a power transmission shaft or that sort of object. Hardness is also a very crucial test method that people do because uh, most of the parts wear and tear and they get worn out and damaged. So hardness is also key for performance. And impact testing, so that any sort of sudden dynamic load that object is going to experience, whether that material is going to withstand that sort of load conditions, that is also being checked. So there are Sharpie and ISO type of impact test. What it essentially does is you make a specimen out of that material and you keep it, and with the swing you try to break it, and how much amount of potential energy that swing was having, that is recorded. And that's how this test happens. So there are different ways of characterizing the material behavior. So this is just a mechanical aspects. So coming back to the 3D printing, so how that sort of material behavior can be used in an advantageous manner so that we can get the desired geometries and material properties. That is something of our interest, and that's our core agenda today. So I will not be going into a patented system that we are going to discuss anyway in the next webinar. But again, you can look at it, the raw feed, how it can be processed to a specific automations and get the different sort of outcomes in terms of applications and its geometric makeup as well as its strength and appearance. So that is something people look at, and most of the commercial people as well as most of the laymen, they don't look at the details of technology. They don't focus on how. What they want is what and why I should go for that. So that needs to be as a information uh, very readily available whenever someone needs to be convinced about use of 3D printing. So first thing, what it is, what is its geometry, what is its mechanical strength, what is its physical properties, chemical properties, and how I can utilize it in end use applications. That is something of end users questions, and why I should use it, because if there are conventional ways they are getting those objects, what is the value addition that this technology is going to bring? That needs to be solved. So uh, that needs to be convinced as well as communicated effectively. So you can see over here, in case of dentistry, there had been very conventional and tedious methods, but nowadays with the 3D printers, you can make custom molds, you can make custom fitments and cure any sort of trouble zones of teeth, replace them, make some sort of cavity fillers, some sort of caps which are with a hard material like cobalt chrome, or those sort of arrangements are getting very popular. And it's predicted that in dentistry, within next 5 to 10 years, every dentist will be having at least one desktop 3D printer in order to plan for his clients certain procedures. So that is one thing. In case of students and surgeons, they are getting realistic well, where they can practice certain surgery, they can have a judgment that how deep a specific organ or specific access that and do the surgery successfully. So that is something very powerful for them as well. Similarly, using powder bed fusion, you can achieve different colors, elasticity, texture, and you can, in early phases of design, take a miniature model, look at the cross sections. All that sort of applications are getting the properties of desired outcome and expected use. So that is something very crucial. So this was just a placeholder for materials in context of different 3D printing technologies. So the first one is, most of them are thermoplastic polymers which can be melted and again resolidified. So thermoplastic property is the one where with the heat you can make it fluidic, and it will flow through channels or extruders and all that sort of stuff, and you can get the desired outcome objects when it is cooled down and solidified. Similarly, there are thermoset kind of polymers, and I mentioned that photopolymerization I will explain in brief. So over here we'll discuss that. So these kind of liquids are a photopolymer. So they are monomers of acrylates, and there are certain catalysts which are photoinitiators, and on exposure of a UV light or a regular spectrum light, that laser beam can solidify the material and you get the desired outcome. So over here, some of the in progress type of components as well as some of the outcome finished goods I have shown. So in case of liquid bed type of technologies, that's a precursor. Now those liquids can be like inkjet, uh, using multi-jets, you can have a different sort of color, texture, and mechanical properties in a single build. So the anatomical model is excellent example of that. So you can see the bone structure as well as soft tissue, and the top layer is made transparent so that you can see through. So that sort of properties are being achieved because of different makeup of the automation that enables that to be done. But materials are as well playing a huge part. The materials, if they are assisting the process, then you get a desired quality and brilliant results Okay, so I will go over to the metal side now. In case of metal, either you can feed with the wires or you can feed with the powders. So there can be different techniques. Either it is a powder bed fusion where sol- solidification of the powder is happening with the either laser beam or electron beam, or it can be simply be binder jetting and later on sintering process. So typical outcomes of that are in either aerospace, automotive, and oil and gas industry. So a lot of metal alloys and different mix and variety of metal alloys are needed, and it's a very huge discipline in itself. So powder metallurgy as well as the conventional metallurgy, you can pursue it as a career. And in case of 3D printing, it is opening up a new door. So powder metallurgy is getting popular and it is elevated to a totally different level where how you can characterize, make a makeup of the specific alloy, how you can process it successfully, get its quality as desired conditions. That is something evolving continuously. And although ferrous and non-ferrous grades like aluminum, titanium, inconels, stainless steels, these were very robustly adopted and getting into the mainstream. There had been recent efforts to qualify copper and uh, tungsten, these type of alloys as well, which were difficult earlier, and people have cracked the methodology and the science behind it. And nowadays, you can get those those grades of material fed or a wire fed machines can be, and you can locally reheat and melt and cool down and solidify that sort of material, and you can get a different sort of geometries. Okay, so again, second poll. Over here, I am taking a brief break so that I will get some of the questions from you answered, and uh, then we will go to the further detailed topics about how those materials are made, typical applications, how the advancements are happening. So, Sankha, can you run the second poll?
Yes, sir. I'll be running the second poll right now. Kindly request everyone to pitch in your answers. This is regarding your how did you reach this webinar? This is for a marketing exercise. Thank you so much, and I would love for you to give your feedbacks regarding
Yeah,
this.
this poll I requested to answer because how we are reaching out and connecting what sort of audience, what sort of demographics, and the awareness is something very crucial for us. And we are also sharing with you a lot of material that you can refer to if you are academically inclined, and uh, your focus is to pursue certain research and development sort of activities, or coming up with a brilliant solutions for the industry, or if your purpose is just to learn and reapply in your industry and your projects that you are taking care of. So we had two sets of webinar series we done in past, as I was briefly speaking at the beginning of this webinar. So first one was innovators at home, where we covered 5 topics. So that was also with the basics of 3D printing, but uh, with the focus of industrial professional engineering clients that we regularly deal with. So it was to be in touch with. Uh, so second webinar series we had is with their request. Based on the first webinar, they asked us to cover certain advanced and focused topics. So you can refer to those 3 webinars as well. So we covered the specific applications in tooling industry like conformal cooling for molding, then topology optimization for how you can do the efficient engineering and redesign the parts better suited for additive manufacturing and 3D printing. And we covered the adoption of additive manufacturing that is happening at a rapid pace in the power sector. So be it energy sector where extraction and processing of the uh, fuel or any sort of energy producing substance is handled, or power generation units where turbines are installed, and how 3D printing is changing the ball game in that sector as well. So let me now, if Sankha is ready with the poll result, I can take a look at it. Otherwise, I will go to the core topic again. So now I will
Sir, you can continue. This poll result I won't be publishing right now. We can
okay.
continue with this, with the
Yeah.
presentation.
Now I will speak about the polymer grades. Again, don't focus on the just acronym. So look at what it can do for you. So how it is easy to do printing, that should be the first question coming to you when you are talking about 3D printer materials. So how it is easy to print, its visual quality and appeal, uh, how much stress and load it can bear so that it will perform in the end use application in a duty cycle. What is its strength in terms of elongation at break, or impact resistance, or layer to layer adhesion that it can guarantee, or certain heat resistance or flame retardant applications are also expected out of certain polymer objects. So the typical grades in case of filament based fuse deposition modeling method, those are polylactic acid, ABS, that's the acrylonitrile butadiene styrene, PET is polyethylene terephthalate, nylon is polyamides, thermoplastic elastomers, and polycarbonate. So these are the typical grades used in filament polymer based manufacturing using 3D printers. Similarly, in case of metal, you can either have a bronze, copper based alloys, or stainless steel, and those sort of metal alloys in ferrous grade and non-ferrous grade as well. So again, going back to polymer. So first I covered polymer filaments and metal filaments because the format of the filament, it can be remembered easily. Now I am going into a powder bed type of platform and sharing different grades of polymers as well as metal. So in case of polymer, nylon was the first one that got popularized. So nylon being polyamide being a substance which can be locally melted very easily and resolidified, and it is not having a very huge shrink profile, so it can retain the shape robustly, and the heat affected zone area doesn't get deformed very easily. So that's the reason why nylon was the first one to get qualified. Later on, certain composite mix up with the aluminum or glass filled or carbon fiber filled, that sort of nylon grades became popular. Nowadays, polystyrene is possible on this platform as well. Another recent news that I heard was polypropylene is also successfully qualified. So polypropylene being a very regularly used consumer grade uh, polymer. So that is something as a breakthrough that recently has happened. So similarly, in case of metal, there are huge number of alloys being looked at and qualified. Austenitic stainless steels, different sort of cobalt chrome, copper alloys, duplex or special stainless steel, tool steels. Maraging steel is a kind of a tool steel. Martensitic stainless steel alloys. Then nickel alloys like Inconel, CM247. These high temperature application alloys. Similarly, titanium is also another grade where high strength to weight ratio kind of components for aerospace are used. And titanium is also popular in case of orthopedic surgeon looking for that sort of solution where component of a metal can be absorbed inside a body as a structural member where a bone is either destroyed in a crash or accident, unfortunately, and replacement is being looked at. Then titanium is a very popular alloy in that category. So these are the typical powder fed type of metal alloys possible. Similarly, now I will move to the liquid based resin polymers, since I covered filament, both metal and polymers. then powders, both metal and polymers. Now, in case of liquid, only polymers can be there. So the liquid resins are either acrylate, so polyacrylate based resins which are clear, or polycarbonate as well clear. Then standard other kind of resins which mimic the ABS like behavior, or other grades of uh, polymers. Those are again based on acrylate. Certain castable resins are possible. Either you can use wax, or there are certain polymer grades which are very easy to melt at lower temperature, and it almost behaves like a wax, and you can use it as a jelly wax substitute, and it is being used in the industry very regularly. As I mentioned, in case of dental applications as well, a lot of dentists are planning the dental procedure by mimicking the structure of a makeup of a teeth. Yeah, so that is very popular as well. Certain elastomers are also possible. So thermoplastic elastomers, I mentioned TPU. So that sort of resins are can be 3D printed, and certain composites can be made as well. So you can have a photopolymer base, and on top of that you can add certain ceramic infill, and you can get a good quality tough type of outcome and parts. So now moving on to how we adopt the characterization methods. So I'm specifically sharing example of metal because that's the everyday problem solving I'm doing for our clients. So we have a raw powder that we obtain from the powder suppliers, and we do the process planning and make the tensile coupon samples and other kind of impact test samples, as I briefly mentioned, and we do the characterization and find out its acceptance criteria and whether we are meeting that, and that ensures the quality compliance for our products that we produce in our facility. So now I am covering some non-traditional methods, uh, how these materials are being manufactured, and some very advanced applications. So one of such metal which is very difficult to do. So there is a misconception that all materials can be processed very brilliantly and superiorly, but glass is one of the exception, because glass usually melts at 1800 degrees Celsius. So it's very difficult to work with type of substance in order to melt it and resolidify. In case of resolidification as well, the shrinkage profile is not that stable. So you need to do a lot of R&D type of effort. So these are few trials done by MIT lab, and they had managed to adopt the filament based, extrusion based type of principle, where they are melting and extruding the material, depositing layer upon layer. But the resolution and accuracy is something that no industry can adopt. So it is just remaining as an artistic method. Beyond that, there are no use cases found so far. But there is research still going on so that they can reduce the layer thickness and process this much more brilliantly. So moving on to the how the materials and production happens in supply sourcing. So most of the polymer, as you know, those are petrochemical derivatives. So the petrochemical industry forms those sort of grades of polymers that I mentioned from crude oil. So those can be transformed into filament using the extruders, or it can be atomized using the cyclone atomizer or a spray technique, those sort of technique. Recycling is being looked at very seriously in case of 3D printed type of industry as well. So conventionally, a lot of polymers are going in landfill and being a waste in the society and nuisance for the society. So people are looking at how can we adopt and utilize the recycled kind of plastic grades and use it for 3D printers. So certain byproducts of the recycling industry, the polypropylene and those sort of grades, if it is purified, are still being utilized in conventional way. But the polylactic acid or certain PET material which is recycled, or PVC, that sort of material, if it is recycled, people are looking at 3D printing to make it something useful out of just waste lying in the landfills. So that's also getting very popular in terms of supply sourcing alternatives than the conventional expensive supply from petrochemical industry. Now taking a look at the metal powders. So powders are formed either using water spray jet technique where melt pool is with a jet atomized. Similarly, gas atomization is also popular cold stream of gas, inert gas is fed to a melt pool and it creates the powder. But in both cases, the granules formed out of that so 3D printing like a cold spray technique or direct energy deposition type of technique. But in case of powder bed fusion, you need spherical type of powder character so that it is easy to flow. And those sort of powders are made using rotating plasma electrode method where helium inert gas is supplied and a plasma state, that's another state of metal. Up to that level of heating is achieved, and under the centripetal force, those particles go and cool down and form the spherical shapes. And this is the most desired technique, and we have suppliers who can produce good quality powders using these type of technologies. And we are utilizing ferrous and non-ferrous alloys like titanium, inconel, stainless steels, tool steels, aluminum, cobalt chrome. All these sort of alloys we are getting source and producing those components as per the technical requirements, as per the geometric makeup, as well as the physical strength specified by the industrial clients. So I think I covered most of the core webinar where I wanted to share absolute basics, which are the material properties, physical properties, the way those materials come into existence in terms of production techniques, how you can characterize. And as there's a very popular and well-known saying, garbage in is garbage out. So as much good quality substance you can feed into, it's like human body, right? We are very careful what we take it as our diet, our food every day. So we prepare our meals very carefully so that our system can function efficiently, and our throughput, our energy throughout the day is best. So similarly, in case of industrial scenario or setup as well, you should be looking at best quality powders, best quality methods, best quality proven techniques, and ultimately the resulting outcome is accepted by all industrial players as well as end users. So that is the key. So I'm now sharing some of the novel approaches and some of the breakthroughs that happened. Tiniest material being transformed into very brilliant small scale products to a very large scale product. So this is one of the example of a thermo wood. So it's a composite of wood and thermoplastic which can form a ship hull or a yacht hull that they had made, and it's a kind of a Guinness World Record, and it was recognized by several industrial players. And this is a brilliant use case of a certain waste thermoplastic that you can make a serious and end use kind of a product using it with lightweight material like wood, which is long lasting as well. And with the plastic, when it is fused, it can make something useful for long lasting period. So next example is construction industry. So either ceramics or cemented type of mortar type of substance can be used. So one of the ceramic example is this type of vases, or you can make refractory lining material or certain ceramic applications which are serious industrial use, or certain fun objects that as it is depicted. But similar sort of extruder principle on a large scale, they were able to make house which is equivalent at the cost of buying an iPhone. So you can imagine just with the price tag of 1 lakh rupee or something, if you are able to construct houses, that is a boon for low income families. And it's getting popular in Europe, North America, and they are deploying this type of solutions where calamities has happened and people are affected. Those sort of societies are benefiting from this type of application. And someone took this idea and thought that anyway someday we are going to step on the moon. We have already stepped on the moon, but we are looking for Mars. So for that sort of mission we need a layover. So why don't we make this type of pods or big houses on the moon, and so that we can have a layover. And in case of Mars as well, you need that sort of a layover of a longer duration over there, because the window of opportunity for travel is very small, and if you miss that, then you are locked down. And nowadays this type of research and development is happening, that how it should be constructed using the local material available on the those sort of foreign bodies or the celestial bodies. Looking at the characteristics and the materials over there, and how it can be transformed to shelter, because wind in case of Mars is very little, so it blows at very high speed, and you need a protection and cover from that. And these are the brilliant examples. So they had made a full scale house as well. This is interior of that sort of a 3D printed constructed pod. Now going on to the food as well, since we are looking at space applications and going beyond our horizons, then how you can store the food and make something that is nutritious as well as delicious. So that is being looked at. So you can mechanize the food making. So pizza is very popular. They first looked at pizza in space, and they were successful to store the substance very easily for prolonged duration, and they were able to form the pizza out of uh, that sort of 3D printer, and other food substance as well being looked at. So certain popular materials are jelly based, uh, cheese based, or starch based. So it can be either sugars or cellulosic starch or mashed potato type of thing, or chocolates. Those sort of powders as well can be bonded with some sort of a sticky adhesive, just a sugar syrup you can imagine. So that is something being looked at, and the same platform you can use it to make food items as well. So that's how people are being disruptive. Then another example is in a very serious application being looked at in a research and development for organic substance to be printed. So they are looking at collagen kind of scaffold making, so that someone who get disfigured or dismembered with some living tissues and cartilage, that those can be replaced, and plastic surgery can be done. So those sort of bioinks are being looked at. Then for quick healing of bigger wounds or burn marks, those sort of bioinks can as well make artificial skin which can grow on top of the wound. That is being looked at. Similarly, in case of bone, as I mentioned, the foreign body of a metal sort can go bad, because it can be rejected by a body. But they are looking at biocompatible substances that you can print, and the body can absorb and grow on top of that. So that is being looked at. So these type of applications are very popular. Then at bigger scale, I showed example of a biggest ship hull that they can produce single-handedly using automation and 3D printer. Similarly, how small it can go. So you can see 10 nanometer resolution type of 3D printing. So over here you can see this is the needle hole, and the bigger body over here is a hair cuticle. So uh, our hairs are almost like 100 nanometer across. So it is going to the level of tinier than our hair cuticles. So that is the level of brilliance being achieved. And some of the objects made using those sort of technology, you can see the level of detail is pretty brilliant. So this technique is called nanoscale 3D printing using two-photon photopolymerization. So the similar sort of liquid resin gets polymerized, but the scale at which it is exposed to the light is of very precise manner, and that's how they are able to achieve these tiny scales. And it's in a micro scale sort of mechanisms making for micro scale applications, electronics, certain sensors, yeah, that sort of stuff are being made by using this type of technology. Or sometimes very tiny sort of transparent lenses that you can make as well can be used in specific applications. So those are being made using this type of technologies as well. Then, yeah, last time we got a question that what is 4D printing. I tried to answer it, but the visual is the best answer than audio. So that's why I'm showing over here a visual of that. So we know that in case of a one-dimensional information, we knew only counting with lines like this. But with the two-dimensional, when we were successfully able to jot down on a piece of paper, draw, we could communicate, we can articulate, we can write symbols, make language, all that sort of innovation has occurred. And up to the certain extent that you can replicate certain old architecture models. So if you are looking for architecture model of a Taj Mahal, there had been certain old uh, pamphlets or layout planning type of discussions that you can refer to looking at the historical data, and you can make a scaled model referring to that sort of 2D drawings. So nowadays we are talking about 3D. So in case of 3D, you can store even more good amount of information for prolonged duration. So how the geometric makeup was, what its processes was, that is being documented. So what alloy was used. That's a product life cycle management uh, overall enterprise written around the core three-dimensional information. So what is the fourth dimension? So the fourth dimension is how the material behaves and how you can tweak its behavior and utilize it for your advantage. That is being looked at. So you can have a geometry prepared in a certain three-dimensional shape, and it can change its property because of certain processes like heat transfer, or because of shape memory type of alloys, or because of certain dissolving such a certain makeup of that geometry that changes its shape. So those sort of applications are being looked at, and those are under the umbrella of 4D printing. So you can see the shape memory kind of applications and all use cases in case of space as a just a concept depicted, that you can have a shape memory type of solar panels which can change its orientation and deflect so that it is efficient during certain orientation and get as much sunlight or any sort of that sort of photo based photovoltaic based generator acting with the solar panel. So that is being looked at very seriously, and some of the examples I try to include over here just to demystify what is 4D printing. Now what lies ahead in future? So can it go even one step ahead? I'm trying to end at the very elevated pitch or elevated expectation. So what they are talking about is smart type of materials. So each individual constituent can be brilliant to morph a shape as per desired use cases. So one of the example is in robotics. We haven't reached to the uh, micro characterization and making very tiny and reliable micro robots yet. But on the meso scale itself, they are able to make certain robots which has a consistent individual element, but when it works in group as a brilliant swarm of robots, then it can morph its shape and deliver certain unique use cases. So the same sort of robot structure can form a different sort of shape and go into a tiny spaces when any sort of tragedy happens and look for living bodies or go and shut down certain critical functions if it is need to be shut down in certain accidental cases. So these type of robots are being looked at, and these type of applications are, of course, academic crowd like you would be looking at, and looking for first conceptualization, then making it happen. So that's why I expose some of those sort of and it is with the understanding of material behavior, processes, and its characterization, and how end use is desired and expected. That first creation and second creation is very important. First creation is always virtually with imagination, and you should back that imagination with the actual realization, the way I described using different sort of techniques. So that's why I end up with the last poll, so that I get a sense that what I covered as a topic is well received, and at what level the knowledge is absorbed, and how I can benefit from you learning, and you can benefit and solve certain challenges that we face as an industry. So yeah, please last poll, and then we are done. We can open for question and answer. Yeah.
Yes, the poll is now live. I would request everyone to kindly put in your answers. That will help us gauging how today's webinar session was. And then we'll be opening up for Q&A session. Thank you, everyone. Please put in your answers. So the poll is live right now. It's going on. You can continue with the Q&A section, and I will publish the results as soon as I get enough inputs.
Okay, thank you. So Ankit, I think in the background you are answering few questions via text. Would you like to answer something on live, or Ashish or Ankit? Hello.
Yeah, hello.
Yeah, Ashish, go ahead.
Yeah, so there have been around 47 questions that have been asked. Actually, 49, 50 questions. A lot of people have asked about what are various videos that we can show for vacuum casting, EBM, etc. So we can actually show them in the upcoming sessions. We'll be talking about 3D printers.
Yeah, we are Ashish, sorry to
Yes,
interrupt.
yes, continue, sir.
Yeah, what I was saying, the way we can construct the geometry using certain material, we are taking it as a separate topic, and we are going to discuss that in next fourth webinar. So we are anyway going to show the techniques. So those videos we will publish on our link as well, on our website, so that people can take a look and have a understanding about how the transformation and how the object formation happens using 3D printers. So that sort of thing we can facilitate. So today we are mostly answering the fundamental understandings about materials and what to expect in terms of quality and the performance out of 3D printed materials. So that is key today. So one of the question I saw, I will answer that. Then Ashish, you can take up and
Yeah,
answer a couple of them, and we can
sure.
wrap up. So
Also,
smart material.
you can follow us on social media platforms so that you keep yourself updated regarding whatever upcomings are there in 3D printing itself. So don't worry about losing out on much. We will be sharing you across on social media. So please make sure you follow us on Instagram, Facebook, as well as on Twitter and LinkedIn. So we will keep you updated on there itself. Thank you. Yes, sir. You can continue.
Yeah, I will answer one question. So Suman is asking, smart material means materials can respond to the environmental changes and change its characteristics as and when it is necessary. Yes, exactly. So the shape memory alloys behave and go back to the original shape after deformation when they are exposed with heat or temperature differences. So that's what I am meaning. So the smart materials are smart in that sense. They adapt to the environment, they perform as expected when certain physical surroundings or chemical surroundings or that sort of changes are happening, and we are expecting more than the normal behavior of a material we are expecting a step beyond of that. So that's the intelligent material or a smart material. Exactly. Okay, so Ashish, you can answer a couple of questions and we'll wrap up. Thanks.
Yeah, sure. Uh, then let me just go through some. Some of them have asked like, how can we print PVC and what process we can use. Actually, we can use FDM process, and that's one way. Fused deposition modeling, which I had explained in the first session, we can print PVC using that technology. And let me take up some more questions. Just hold on. Next, we've got some interesting questions about carbon fiber composites. Like, how can we 3D print that? Actually, we can use chopped composites for 3D printing, and where carbon fiber pieces can actually be mixed with the traditional plastics that we have, such as nylon, ABS, PLA, etc. that Sir talked about right now, and you can print those. And I think rest of the questions, most of them actually have been answered. All of them have been answered actually. So we'll kind of end this session. Shanko?
Yes. So there has been a lot of questions answered on the live chat itself. Thank you everyone for joining in. We'll be sending you a webinar bundle at the end of all the 5 sessions. So don't worry if you have missed a couple of sessions. We would expect you to join us in the next. In the next session, we'll be talking about the 3D printing machines itself, because we have talked about filaments, we have talked about the 3D printing process in general, we have talked about a lot of things, but we haven't talked about the machines in depth. So the next, you'll get to know what the machines are of and everything that goes into the infrastructure of a 3D printing company. Thank you everyone for joining in. Thank you, ThinkRate, for being our associate partner. Thank you, Ashish. Thank you, Rahul sir, for your awesome presentation. To all the participants, and all your questions have been very much appreciated. And keep in touch with us. Do follow us on all our social media platforms. And yes, have a nice day. Thank you so much. Thank you.
So see you all on 24th, 5 p.m. Yeah.
Yes, 24th, 5 p.m. The next date, we'll be sending you the email soon regarding the joining details and everything, and the next session details as well. So yeah, thank you so much. Thank you everyone. We'll see you in the next session. Bye-bye.
Thanks.